Jai Hind. I'm Dinanath Prasad, Department of Electrical and Electronics Engineering. I'm going to discuss today about the load curve based numericals. So in the last lecture, I have discussed what is load curve and what are the different terminology we can use in a load curve, how to make load curve, what are the advantages we get from the load curve, what are the information basically we get from the load curve. So based upon that, in this lecture basically I'm covering only on the numerical part, how to get the knowledge and how to evaluate things from the load curve. So first of all, this is the first numerical based upon the load curve. If any generating a station, let's suppose this is of 1 megawatt supplied to a specific region which has the following demand, like from the midnight to 5 am, the load demand will be of 100 kilowatt. That is from 5 to 6 pm there will be no any kind of load. This is not possible, but in the numerical case we can take this is no loading condition from 5 am to 6 pm, and from 6 to 7 pm the load demand of 800 kilowatt, and 7 to 9 pm of 900 kilowatt, and 9 pm to midnight that is of 400 kilowatt. So from this data we have to know, we have to evaluate this is daily load curve, monthly load curve or yearly load curve. So this is clearly shown in this in this table. The data is starting from the midnight to the midnight. So this data is taken for the 24-hour, means this is daily load curve. This is the time sequence for the one day, and this is the demand which is varied time to time. So if we plot, likewise if we going to plot the load curve, this is the time and this is y-axis is demand. So you can see the maximum demand we taken as 900 kilowatt on the sequence from 7 pm to 9 pm. So first of all we divide it total from midnight. Let's suppose it is 0, we can divide it into 4 sequence or 2 sequence, like 4 pm, 8, 12, then 4, then 8, then 12. So this is the time, and the maximum demand is 900. So we divide as 200, 400, 600, 800, something here is 900 here. This is in kilowatt. So you can see from 0 to 5, 0, let's suppose there is a 5, 0 to 5 there is a 100, there is a 100 kilowatt. Let's suppose this is 100 kilowatt. So 0 to 5 am, this is of 100, this is 5 am. So this is pm. So let's suppose here this is of 100 kilowatt loading. 5 am to 6 pm this is of 800, and this is of 800, 6 to 7 this is of 900, this is of 900, and 9 pm to midnight of 400. So based upon this data we can plot. This is load curve. This is something varied, but likewise we can make load curve from this data. So we can decide from the which sequence will be the maximum load. The maximum load sequence will be from 7 to 9 pm of 900 am. So from this data we have to calculate, first of all, plot the daily load curve and load duration curve. We have to plot, like we decide, we can make here daily load curve, load curve, or load durations curve is plotting for the higher demand, next demand, up to next demand. Next we have to calculate the load factor. How to calculate the load factor? Next we have to calculate the reserve capacity, plant capacity, plant use factor, the hours that the plant has been off, and the utilization factor. So these factors I have to calculate from this data. So first of all, based upon this data, we have make a load curve, that is the variance from load with respect to time. This is daily load curve from midnight to 5 am is 100 kilowatt. From 5 am to 6 am, 5, this is 5 to 6 pm means 18 hour. This is no load, there is no kind of load, but it is not possible. From 6 to 7, from 6 to 7 event, 6 to 7, that is for 1 hour there is a 800 load. From 7 to 9, this is of 900, this is the maximum. From 9 pm to midnight, this is 400 pm. So this is the load curve. If we make from load curve to daily load duration curve, first of all we take the maximum load on the first, then second or the proceeding load, third, then the proceeding load, that is of 400 kilowatt, then fourth one is the 100 kilowatt from midnight to 5 am. After that, from 5 am there is a no load, means load will be switched off up to the 24 hours. So first of all we have to calculate the average load. How to calculate the average load? Then we have to calculate the area under the load curve, means what will be the area covered by this load. By this we have to calculate. If we know the area under the load curve in kilowatt hour, and if we divided it by number of hour use, then we will get the average load. So how we will calculate then average load? We will know the durations. From this durations to this duration is 5 hours into load we use as a 100 kilowatt. So we multiply 5 into 100. Then from this duration to this duration means around 13 hours there will be no load, means we will put 13 into 0. There is a durations of 1 hour from 8 to 9 of 1 into load will be used of 800 megawatt. So 1 into 800 plus there is a durations of 2 hour of load being used of 900 kilowatt. So we multiply by 2 into 900 plus we multiply the last hour is for the duration of 3 hours. So we multiply by 3 into 400. By this way we calculate what will be the area under this load curve, and this load is divided for the 24 hour. So as it is a daily load curve, then we divided it by 24. We will get the average load, that is 4,300 kilowatt hour divided by 24 hour. We will get 179.16 kilowatt, which is the average load of the particular loading conditions. Now we have to calculate the load factor. How to calculate load factor? For the calculation of load factor we have already discussed. First of all we have to know what will be the average load and what will be the maximum load. Average load we have already calculated in the last calculation. This last calculation we will get 179.16 kilowatt, and the maximum load from we can see from this table from 7 in the instant of 7 to 9 am, 9 pm, that is of 900 kilowatt. We will get load factor is 0.199. So this information, that is the information of load factor, we will get from this load curve. So this is of in a percentage only 19.9 19%. So this percentage is very less. So we can know what will be the load factor from this load curve. We having already discussed, load factor cannot be more than 1, because average load should be higher, always higher than the maximum load. So load factor will be always higher than 1. If we talk about reserve capacity, what will be the reserve capacity of the power plant? So we have to know what is the installed capacity. Installed capacity is already given in our problem, that is of 1 kilowatt, that is 1000 kilowatt minus of subtract on the maximum demand. Maximum demand is given, that is of 900 kilowatt. If we subtract them, we can get to know the reserve capacity of this plant is 100 kilowatt. Now come to plant capacity factor. What will be the plant capacity factor? If you are going to calculate the plant capacity factor, we have to know the average demand, which is already calculated in this previous problem, and we have to know the installed capacity. Installed capacity is already given. So if we divide it by average demand by installed capacity, that is 169.79.16 divided by 1000 kilowatt, that is again 0.1791. In a percentage, we will get 17.19. Again, the plant capacity factor is always less than 1, because installed capacity is always be the higher than the any average demand. Now we have to calculate what is plant use factor. So plant use factor is being calculated by what is the actual energy produced in kilowatt hour, that have been calculated previously, upon be divided by plant capacity. What will be the plant capacity is given in the problem, and now number of hours being used. So number of hours being used is 11 hours. So if it is divided by all that is given, the plant use factor for this case is 0.3909, or in a percentage term, this is 39.09. Now the utilization factor is calculated. We know the maximum demand divided by the installed capacity. Maximum demand is already getting from this table, that is of 900 kilowatt. Installed capacity is given, that is 1000 kilowatt. Again, we will know installed capacity is always higher than the maximum demand, then the utilization factor is always less than 1. Now another problem, in any generation station has a maximum demand of 20 megawatt, a load factor is given of 60%, plant capacity factor is given of 48%, and the plant use factor is 80%. We have to calculate this following point, like we have to calculate what is daily energy produced, what will be the reserve capacity, how much number of the operating hours per day daily used, what will be the maximum energy that could be produced daily if the generation station was running at all the time. So these are the points we have to calculate. If we having the maximum demand is given, load factor is given, plant capacity factor is given, plant use factor is given. Based upon that, we have to calculate these all points. So we know that average load is nothing but average load factor is average load divided by maximum load. So average load is given in this problem is 60%, that is 0.6. We have to calculate the average load, and maximum load is given in this problem, that is of 20 megawatt. We can calculate the average load is 12 megawatt in this case. Similarly, average load we will calculate as a area under the load curve. What will be the area under the load curve? And the load duration. This is again the daily load curve. Daily load curve means the total duration of the load curve is for 24 hours. So it is divided by area under the total load curve divided by a number of hour. We will get to know what will be the what are the areas under the load curve, that is the total energy produced, that is 12 into 24 hour, that is 288 megawatt hour. This is the average load for this case. Now we have to calculate the reserve capacity. What will be the reserve capacity? For knowing the reserve capacity, firstly we have to know the what will be the installed capacity for that particular stations. Maximum demand of the power stations is given in this problem. So installed capacity we calculate by average demand by plant capacity factor. Average demand is given in this problem, that is of 12 megawatt, and plant capacity is plant capacity factor is calculated as 0.48. From that we can know the installed capacity. Now if we know the installed capacity, we can simply calculate the reserve capacity is installed capacity minus the maximum demand. Maximum demand is given in this problem is 20. Likewise we can get the reserve capacity of 5 megawatt. Now we have to calculate the number of operating hours per daily, how much used. We in this problem given plant use factor is 80%, and the average demand we already given in this problem. Time durations, this is durations for daily, this is daily load curve. So this is for 24 hours. So we multiply average demand into 24 hour. Plant installed capacity is already calculated, that is of 25. We have to know the what is the operating hours. Operating hours we calculate simply of 14.4 hours we can use. This important information again we will get from the load curve. Another thing, we have to calculate the maximum energy that could be produced daily if the generation station was running at all the time. So for the what will be the maximum energy that could be produced, we have to know what will be the installed capacity. If we multiply installed capacity by the 24 hour, we will get what will be the total maximum energy produced. So we will multiply installed capacity is given 25, already we calculate into 24 hours, we will get the 600 megawatt hour will be the maximum energy that could be produced daily. This is another problem is given. This is now third number problem. In this problem, given the generation station having capacity of 10 megawatt, this 10 megawatt have to supplied any two region, let's suppose any southern region or eastern region. Their region time slots are different, their demands will be different, but the generating station will be same. Means one generating station supplied power to their different region. Their different regions will be region A or region B. So the data is given in this region. For the region A, from midnight to 9 AM of the capacity of 600 kilowatt. From 9 AM to 12 noon, it is given of 2500 kilowatt. 12 noon to 5 PM, it is given of 800 kilowatt. 5 PM to 6 PM of 5000 kilowatt. 6 PM to 7 PM, this is no load, there is no any kind of load. From 7 PM to midnight of 4000 kilowatt. So we can get from this data from the duration of 5 PM to 6 PM of 5000 kilowatt. This is the maximum demand. Maximum demand for the particular region, particular one region. And in another region, region B, let's suppose from midnight to 8 AM of 100 kilowatt. From 8 AM to 1 PM of 5000 kilowatt. 1 PM to 2 PM, this is 800 kilowatt. From 2 PM to 5 PM, this is again 5000 kilowatt. From 5 PM to midnight of 800 kilowatt. This is data is given. So again we will get to know from the region B from 8 am to 1 pm of a maximum capacity of 5000 kilowatt, from 2 pm to 5 pm of maximum capacity of 5000 kilowatt. So based upon these two regions are given, region A and region B are given, the supplied are same, we can add them according to time sequence from like midnight to 8 am. The total capacity is in this duration is 600, and for this duration from midnight to 9 am it included 8 am also, 8 am. So this is midnight to 8 am is constant from both from the region, and their capacity is using 600 and 800. So simply we add 600 plus 800, that is 1400 kilowatt from 8 am to 9 am. Again from the common from both of these region, for this sequence the capacity is 600 plus 5000, that is 5600. 9 to 12, this is 75. 12 noon to 1 pm of 5800 kilowatt. 1 pm to 2 pm of 1600 kilowatt. 2 pm to 5 pm of 5800 kilowatt. 5 pm to 6 pm 5800 kilowatt. 6 to 7 800 kilowatt, and 7 to midnight of 4800 kilowatt. So after combining both of the region, we will get to know on the which sequence there will be underloading, and in the which sequence there will be overloading. So you can see in this table from 6 pm to 7 pm the load will be usable load will be 800 kilowatt. This is least, and from the region 9 am to 12 noon of 7500, this is higher. So based upon that we have to calculate maximum demand of the power plant is given, that is of 7500 kilowatt. So we have to know what is the diversity factor. We know diversity factor is always greater than 1, because maximum demand of the power plant is always less than the sum of the individual maximum demand. So in this case you can see the maximum demand of the power station is given 7500. Individual maximum demand, if we calculate maximum demand for the number of service region 1 is 5000, and for the region 2 is again 5000. So if we add them, that is we will get 10,000 kilowatt upon 7500 kilowatt. That diversity factor is greater than 1, that is 1.333. This is the diversity factor of the given load given plant. Thank you.